So, what if the most chaotic, most destructive objects in the entire universe, black holes, were actually secretly governed by the purest, most elegant rules of mathematics? Well, today we're going to dive into a discovery that is just shocking. It builds a bridge between two worlds you'd think could never, ever connect: the physics of gravity and the pure abstract logic of number theory.
Okay, so to really get how mind-bending this connection is, we first have to appreciate just how different these two fields are. Let's meet the two main characters in our story today.
On one hand, you've got physics. It's all about the tangible, often messy and chaotic reality of our universe. You know, the intense gravity, the warped space-time around a black hole, real physical stuff. And then, on the other hand, you've got number theory. This is a pristine, totally abstract world of pure logic. It's home to things like prime numbers and beautiful equations that exist only in our minds, completely separate from the physical world.
I mean, at first glance, absolutely nothing. They seem to be complete opposites. And yet, a truly groundbreaking discovery has revealed this profound, totally unexpected link. So, let's start with the first piece of this incredible puzzle.
Our journey kicks off in one of the most extreme places in the cosmos you can imagine: the very edge of a black hole. This is where our first clue pops up.
The key to all of this is a really powerful idea called the attractor mechanism. Basically, it says that no matter how complex or messy the geometry of space-time is far away from a black hole, as it gets pulled closer and closer to that event horizon, all that complexity just gets wiped away. Everything is forced into one single, simple, stable state. It really is like a cosmic reset button.
Picture this. Imagine a ball rolling inside a big bowl. It doesn't matter where you let it go along the rim, high up, down low, to the left, to the right. It always ends up at the exact same spot at the very bottom. Well, the attractor mechanism does the same thing, but for the geometry of space-time. All the initial messiness gets smoothed out, and everything converges to a single, inevitable state that we call the attractor point. So the huge question is, what is this point? And this is where our story takes this incredible turn, shifting from the world of physics into pure mathematics. This is where we see that unexpected bridge between the two worlds.
This right here is the heart of the discovery. That stable attractor point isn't just a physical state. It turns out it corresponds perfectly to a very, very special kind of mathematical object, something called an elliptic curve with complex multiplication. Now, these are not just any old curves. They are incredibly rare and have this beautiful, high degree of symmetry. It's just amazing. The physical properties of the black hole's horizon are perfectly described by the arithmetic of that specific mathematical curve.
Just let that sink in for a second. Out of all the infinite possibilities out there, the chaotic physics right near a black hole spontaneously picks out a mathematical structure that number theorists find exceptionally interesting because of its unique symmetries and properties. The laws of gravity are, literally speaking, the language of pure math. It's wild.
But wait, the connection doesn't even stop there. This is way more than just a beautiful coincidence. It actually suggests that black holes might hold the keys to some of the oldest, most stubborn, unsolved problems in all of mathematics.
The stakes here are just enormous. It turns out that these specific mathematical structures, the ones coming from black holes, are central to solving a legendary 50-year-old problem called Kroneker's youthful dream. And this problem is part of a famous list of the most important unsolved questions in all of math. It's all about finding a deeper way to generate and understand the very nature of numbers.
So this is the full mind-bending chain of discovery. You have physicists who are studying these theoretical black holes to try and understand gravity, and they just stumble upon the exact kind of structures that mathematicians have been hunting for to solve a foundational problem about the nature of numbers. It's like a tool for number theory was forged in the heart of a black hole.
And here's a little detail that just makes this story even better. The physicist who actually wrote the paper and found this connection, he freely admitted, right in the paper, that he knew very little number theory. This wasn't some deliberate search for a connection. It was a complete and genuine surprise, which just goes to show how deep and unexpected this link really is.
So, we have this incredible, unbelievable bridge between two totally different worlds. But what does it all mean? Let's unpack the really profound implications this has for how we understand reality itself.
Okay, so if you take away anything from all this, it should be these three crucial points. First, physics and pure math are having a hidden conversation. They're speaking the same language. Second, this creates a whole new toolbox. Physicists can literally do calculations about black holes to give mathematicians new things to study. And finally, and this is the big one, it points toward a fundamental unity, suggesting that the physical laws of our universe and the abstract logic of numbers might not be separate things at all.
And this discovery leaves us with a truly provocative question. You know, we usually think of math as a tool that we use to describe the universe. But what if it's the other way around? What if the universe itself is just an expression of mathematical truth, and the laws of physics are just one of the ways that truth shows up? This bridge between black holes and numbers, it doesn't just give us answers. It completely changes the questions we even know how to ask.